Today let's talk about solving absolute value inequalities. Now to start out, we're going to start with kind of an easy one. The absolute value of x is less than 3. Now let's remember, absolute value means a distance. So this is saying, what are all the numbers that are a distance of 3 or less back to 0? So if you think about the number line, here's 0. And then what are all the numbers that have a distance back to 0 that are less than 3? So that would be all these numbers in here. And then also remember that would include these numbers over here as well. So you'd have, if you just talk about integers, you'd have numbers like -2, -1, 0, 1, 2. Okay, so it would be all those numbers there in terms of integers. I know there's fractions and decimals that would also be a part of that. But that's what we're talking about when we're talking about what are the answers to the absolute value of x is less than 3. Well, how do you solve that without having to go through kind of like this picture idea? Well, whenever we talk about absolute value inequalities, what we're going to do is we're going to change these absolute value inequalities into compound inequalities. And if you remember, compound inequalities were split up into two different types. There were AND statements and OR statements. So we're going to first identify an absolute value inequality as, is that an AND statement or is that an OR statement? So let's start with the AND statements. AND statements are pretty easy to identify. It's any time that you have a less than or equal to sign in the problem. So less than is AND. Easy way to remember it. And what you do is you, for instance, let's just take this one. That's the example of this right here. We're going to take this problem here. We're going to write x is less than 3 and greater than -3. And this part right here that we just created is what is accounting for this part on the left-hand side. And there you go. That's how you represent all the numbers that have a distance back to 0 that is greater than -3 and less than 3. And if you wanted to put it in solution sets, I would just do this. Now, they're not always quite that simple. For instance, on this one here, number 2, this time it doesn't just say x is less than our absolute value of x, it says x minus 1. So we're going to follow the same steps. You notice here it says less than, again, less than or equal to, so it's an AND statement. So I'm going to rewrite this again, x minus 1 less than or equal to 6 and greater than or equal to -6. So this part over here is always the opposite of this, kind of like how up here this was 3 and then this was the opposite, it was -3 here. And now we're just going to solve that. So I would just add 1. So I'd get -5. And there you go. X is greater than or equal to -5 and less than or equal to 6. Solution sets, I'd put an x here. I did state up here that we should graph it, so let's do that. I forgot to do that on the first one. -5, 6. So greater than or equal to -5, less than or equal to 6, and there you go, just like that. Okay, so let's move on down. Here's another one that's a little similar but yet different. One of the biggest things that you got to remember when you're solving an absolute value inequality is before you do any of this, making it into an AND statement like that, you have to get the absolute value by itself. You have to. So the very first thing I'm going to do here is I'm going to subtract 1 to begin with. So I get the absolute value of 2x less than or equal to 8. Now the absolute value is by itself, so now I can split it up. 2x is less than or equal to 8 and greater than or equal to -8. So now just divide by 2. Let's get -4 here. Get +4 here. If I were to put in solution sets, I would just include that. So remember, this means all values of x, or all real numbers x, such that x is greater than or equal to -4 and less than or equal to 4. We're going to do a number line. -4, here's 4. It's greater than or equal to and less than or equal to, so again, solid dots. And there you go. Okay, last one. So this one, again, the absolute value is all by itself. So we can just go right from the beginning. It says x minus 4 is less than -2 and greater than. Now this one's negative, so I guess I would make this one positive. I would solve. So I would get x is greater than 6 and less than 2. Okay, so let's graph that. Okay, so here's 2, here's 6. This says x is less than 6, or pardon me, x is greater than 6, and x is less than 2. Well, that kind of funny looking here. And maybe as we were going through this whole time, it kind of felt off a little bit, and there's a reason for that. Let's think about this. Let's not just write down what the numbers say. Think about what the numbers say. This says a number is bigger than 6 and less than 2. So is it possible to have a number that's bigger than 6 and less than 2 at the same time? No, that's impossible. Okay, this whole situation is impossible. And even if you go back to the very beginning, notice this says there is a distance that is less than -2. Well, that's impossible. You can't have a distance that's negative. So this whole situation, if you would have noticed from the beginning, you could have just skipped all this work and simply just said, this is no solution. So you got to make sure that you're actually reading the problem and understanding what's being asked of you. Okay, so let's move on. Let's go to OR statements here. So let's start again with this situation. It says, what are the answers to the absolute value of x is greater than 6? So in other words, what are the numbers that have a distance back to 0 that are bigger than 6? So if here's 0 and here's 6, the numbers that have a distance bigger than 6 back to 0 would all be over here. So those would be numbers like, if you just talk about integers, 7, 8, 9, etc., etc. But then over here, we also have all these numbers. We have -7, we have -8, -9, etc., etc. So it's all these regions on two separate parts. So how do we go about transferring this type of a problem into a compound inequality like we talked about before? Well, first of all, this next section we're going to talk about are what we call OR statements. Now, you know an absolute value inequality is an OR statement when it says greater than or equal to. Or the way I like to say it is greater is OR. And what you do is, it's quite simple. You simply write x is greater than 6, so the same thing but without the absolute value. Then you write OR x is less than -6. And this second part right here is what's accounting for this negative section over here. Okay? And then from there you would solve. Now in this case there's nothing to solve. We're done. So we can simply put it in solution sets. I can graph it quite easily. X is greater than 6. X is less than -6. And there you go. That's how you go about creating an OR compound inequality. So let's take a look at this next one over here. It says the absolute value of 3x minus 4 is greater than or equal to 11. Well, let's go through and get the absolute value all by itself. So I'd add 4. So I get absolute value of 3x greater than or equal to 15. Now that the absolute value is all by itself, I'm going to now split it up. So 3x is greater than or equal to 15. Or 3x is less than or equal to -15. So divide by 3, x is greater than or equal to 5, or divide by 3, x is less than or equal to -5. So let's graph it. Well, let's put it in solution sets here first. Graph it. So here's 5 and -5. And there you go. So not terribly difficult. The OR statements are, pretty straightforward. You're just going to continue with whatever this says as this portion. You have to make sure you're using that word OR, and then 3x is less than or equal to -15. So again, you're switching the sign and negating. Okay, so last one. Let's talk about this one. So here the absolute value is all by itself again. So I'm going to start out by just splitting it up. 2x plus 1 is greater than -2, or 2x plus 1 is less than +2. So I switched my sign and negated. So subtract 1. 2x is greater than -3. Divide by 2. X is greater than -3/2. Over here, I'd subtract 1. 2x is less than 1, I would divide by 2. X is less than a half. Now it's or in between. So solution sets. Okay, so let's take a look. Now this is saying we have negative 3 halves greater than, and we have positive a half, and that's less than. Now this is different than all the other two that we just did. Now these have arrows going in opposite directions. Now that doesn't, or pardon me, yeah, opposite directions, pardon me. They're crossing each other. Now that doesn't mean we did anything wrong, except for, let's just think about this again. What's a number that's bigger than negative 3 over 2, or negative 1.5, or less than a half? Well, that would be any number you pick, okay, whether it be 5, 100, negative a million. It's either going to be bigger than this or less than this. So what does that mean? That means this really isn't my solution. My real solution, or my actual solution, is all real numbers. Okay, any number I pick will work. And that means my graph is actually this graph. Okay, a graph that shades all parts of the line. Okay, because again, any number I pick will satisfy either this part or this part. And there you go. There's absolute value inequalities. Remember, all it is really is us just converting them into compound inequalities. And whether it's an AND statement, remember it's less than is AND, or an OR statement, greater is OR, okay, once you realize which one it is, then it's pretty straightforward.